Okay, so next we have number 25. Okay, number 25, you're given a function which is discontinuous already at x equals -3, and you want to make this into a piecewise function by defining another equation, or okay, by defining another function, another part of the function at x equals -3 that would make this entire function, a piecewise function, then continuous. Okay, so let's see what's wrong with this first of all. Okay, why is it discontinuous? Okay, we know that it's discontinuous because the x value obviously cannot be -3. Okay, but nevertheless, this function can be simplified into practically the same graph as y is equal to x minus 3. So it will behave like a line. Okay, the only thing different about this function as opposed to the equation y equals x minus 3 is that the x value is not defined at -3. So it's not a vertical asymptote. Okay, we mentioned this. I talked about this on my video, on 2 videos prior to this one. That x equals -3 is a little hole on the graph. We call that the removable discontinuity. Okay. So give a formula for the extended function that is continuous at the indicated point. The book's answer is this. The book's answer is to take just a simplified answer for this one, y equals x minus 3. Okay, or I guess my approach would be this too. Okay, you could make this into a piecewise function by making your y value to be -3. I should say, I'm sorry, your y value to be -6, because -3 minus 3 would be -6 when x equals -3, or 4, I should write 4x equals -3, or you could just put a comma there. Okay, so whenever x is not -3, you could use the original function, but whenever x equals -3, you could fill that hole, that removable discontinuity, by defining it with the value that it should be under with the behavior of that graph. Okay, or using the limit. Okay, the fact that the limit as x approaches -3 is -6. You could look at this graphically too, just to show you that this works. Okay, so right now, okay, so here you see that's -3. Okay, it's undefined. So all we have to do is okay, for the red one though it's undefined. Okay, now, okay, you see that the intersection, okay, of this particular function and this particular function, that fills in that circle, that removable discontinuity right there. Okay, so there you have it for number 25.